We are on to problem number 10. You guys are almost finished. I hope these videos have been helping you. I did happen to watch I watch every one of them, but I was watching problem number 9 and cannot believe the snorting that I did twice on that video that I'm like, oh, but I'd already uploaded it, so we're going with it. I apologize. Yikes. Don't realize how horrible you sound until you actually video yourself. All right, in this one we have a rocket that is being launched up using this chemical reaction, H2O2, which, ooh, think through in your head. Anybody recognize what that's a formula for? Hydrogen peroxide. I should have brought a bottle to show you. Hydrogen peroxide reacting with a form of ammonium, all right? And, which makes sense, this is aqueous because it's dissolved in water, reacting with that gas. It has a explosive reaction of nitric acid being made, that's what H10NO3 is, and water vapor, okay? That's what we're going to be seeing shot out there. With this, they give us the rocket engine contains 1,500 grams of our H2O2. Well, that's the reason I put it underneath there. An excess of N2H4, so basically that means I can ignore it. What volume of water vapor will be produced when the rocket fires up to a temperature of 540 degrees Celsius, so very hot, and a pressure of 1.2 atm? So I know immediately it's going to have to be the formula PV is equal to nRT just because we have mole amounts involved. Remember, anytime when you see moles mentioned with these gas laws, it can only be PV is equal to nRT. That's the only formula that will work. It's the only one that has moles mentioned. So I went through, wrote down the values I know. I asked for an answer in volume, so that's why I put my question mark. But my problem is I do not have a mole amount for this value either. So before I can go ahead and plug things into the PV is equal to nRT, I need to go ahead and solve for my mole amount. So I take what I have grams of H2O2, and I need to convert that to moles. So I need to find out how much does 1 mole of H2O2 weigh, which is 34.0 grams. Okay, then, so I can cancel out that, always watching your units. I need to go from moles of H2O2 over here to moles of H2O. So looking there, I have 7 moles of H2O2 and I have 8 moles. I don't know if you guys have ever had a large mole conversion like that in one of our problems yet. So definitely, if you don't get this 8 and the 7 right, it's going to throw your answer way off. Sometimes it's a 1/1 and, you know, you can scoot by and get the right answer even though you might not have done it exactly correct. But in this situation, a no-go. All right, we make sure our moles of H2O2 cancel out with moles of H2O2, and we should get an answer of 50.4 moles of H2O. Okay, 50.4 moles of H2O. Great. Now we can go ahead and plug that in for what we know here. And that means over here, because I already rearranged our formula, that's what's going to be right here. Ooh, I got to write mole small. I also didn't convert my temperature yet. Remember, it has to be in Kelvin. Every single temperature given in this chapter or module must always be in Kelvin. So we're going to add to it 273. You're going to see how wonderful I can do math on this fly here. 11, 5, 6, 7, 8. Did you guys get 813? Yeah? Okay. Also, when we're looking at adding this, yeah, we're just going to go with 813. I know the answer key has you use 810 because this value right here, we don't have an actual number in the ones place. So technically, we should be using 810. But I am really fine if you used either one of those values. And I will tell you the difference between the two answers there. All right, so I'm going to plug in actually the 810 Kelvin first. All right. Oh my goodness, Mrs. Farmer, that is not where it goes. I even left myself a space and I still write it wrong. It's an amazing accomplishment. All right. So we should get an answer of 2.8 times 10 to the 3 liters, because once again, I only have 2 sig figs there in 1.2, and I only have 2 sig figs in the 810. Okay, so either one of those would be correct. Now I'm going to go back through and do my 50.4 times my 0.0821. Oh, mercy. 0.0821 times my, and in this situation, I'm going to use the 813 just so we can see what we get, divided by our 1.2. So you might have also gotten a value. Well, you know what, to be honest with you, it's still going to give you the 2.8. Because after you do all that rounding and you only give yourself 2 sig figs, you should get 2. I mean, in the end, if before you put it in scientific notation, excuse me, we should have 2,800 liters. But scientific notation does make it look better. All right, so in this problem, you are going to have 3 points. 1 for doing your stoichiometry correct. 1 for getting all of your units converted correctly. And the 1 for finding the answer of the volume. So we have, once again, this one is worth 3 points. And altogether, for our practice problems in number 12, when we're looking at 4 through 10, we should have a value of 18 points. So watch, I'm going to flip this over. Oh, no, I'm not going to flip that over because I got other things on the back side of it. Let me just put this. 18 points for 4 through 10. Thank you for watching, and make sure you record your grade at the top of your paper and turn that in on Friday.